All right, everyone. So this is the lecture on toxicology of alcohols and ethanol. Anytime I'm going to talk about the three different types of alcohol at the top, and then every time from there on out, I'm going to use the word alcohol for ethanol. So that is, it's probably going to take about 20 minutes, but I thought if I did it this way with notes and writing, it would speed me along, maybe make my handwriting a little bit more legible. So the funny thing about alcohol is I read a study that it actually is the third most popular drink worldwide. Beer. Beer is the third most popular drink worldwide, only behind number one, which thank goodness is water. Number two is tea. So that would make number three beer. So this is a pretty, the most abused drug worldwide. And so I think you definitely, especially since you're going off to college, definitely is something that you need to know a fairly good amount on. So alcohol would really be anything categorized with this hydroxyl group, this OH group right over here. So this is the hydroxyl or an OH group. It is a substance that's made by anaerobic respiration. So it's made by anaerobic respiration. And that's really the only thing that is in common with all the alcohols. Now, like I said, we're going to really focus on ethanol because this is our grain alcohol. The grain alcohol. And its formula is C2H5OH. There's that hydroxyl group. And this is the consumable alcohol, meaning it's the one that we drink. All right, when we're over 21, it's the one that's healthy, legal to drink without consuming too much. The other two alcohols that I want you to know a little bit about, this one right here, the methanol, is CH3OH. It's a slightly different chemical formula, and it's actually considered wood alcohol or wood spirits. And this one actually is super toxic. Only 10 milliliters of it can actually cause permanent blindness. So 10 milliliters of wood alcohol is all it takes to cause permanent blindness. And then the other alcohol that you need to know that's also not safe for consumption, but you probably have a little bit more interaction with, is something called rubbing alcohol or isopropyl alcohol or propanol. And this one's CH3CHOHCH3. And this one, again, is pretty toxic for consumption, so it can't be drunk. It actually can be absorbed through your skin. It can be inhaled, and all of that is dangerous for you. All right, so this one's also an alcohol that we have to be careful with. All alcohols are central nervous system depressants. They're considered depressants, which they increase the GABA inhibitory receptors. All right, I'll talk a little bit about this brain behavior in a little bit. Ethanol, this alcohol right here, is the safest of all alcohols. It produces metabolites that can be detoxified with less consequences than the other types. However, make no mistake of it, it still can be toxic to you, especially in higher doses. Do you remember our last lecture? We said there's an LD50 for everything. So just like every other substance, even though it's the safest, that is used in quotes because it can be toxic in large amounts. All right. Alcohol toxicity is actually related to the metabolites that are produced. Metabolites would be what is this alcohol broken down into when it's metabolized by your body. All right. So during the detoxification process, during the breakdown process in your body, it's broken down into different substances, and that's what's toxic to you. So it's not necessarily the methanol, this wood alcohol, that's toxic. It actually changes into formaldehyde. So it changes into another substance that's super toxic. And that's why that methanol is so toxic in even small amounts. Okay? All right, ethanol is highly metabolized, which means it easily mixes with water. And it disperses easily and quickly as it mixes with your blood. So it's water soluble. So that's something that's really important. That makes it easily picked up by the blood. That makes it easy to cross the, the blood-brain barrier, and access the brain and central nervous system, which is why alcohol causes lightheadedness, dizziness. It also has the ability to pass into the placenta. So if a mom is pregnant, that alcohol can actually go through the placenta and be absorbed by that baby. All right, so that's pretty important too. All right. Something that you need to know as far as the metabolism of alcohol, let's draw a little person here. Let's get him some hair. All right. The first place, let's make him drink something. Make him drink a beer. All right, so there we go. This person's drinking alcohol. And the first place that this alcohol is going to go is into the stomach. Now, that's actually not where this alcohol is absorbed. The alcohol is absorbed in the small intestine. So after it goes into the stomach, it's going to go into the small intestine. After the small intestine, then it goes into the blood. All right, so the quicker that it gets through the stomach into the small intestine and then into the blood from the small intestine, the quicker it's absorbed there, the quicker somebody will feel the effects of that alcohol. After the blood, the fourth spot is the brain or the central nervous system. So it goes from the blood right into that blood-brain barrier, crosses that blood-brain barrier and into the central nervous system. And then the last spot is going to be the liver, where it's filtered from our body. All right, so that's sort of the pathway of the alcohol. A little bit about alcoholic beverages. We do know that it's produced by anaerobic respiration, but when we talk about all of these different ones, I want you to know a little bit about them. The alcohol content does vary according to the beverage consumed. So some are fermented by yeast and used directly. So beer is one of those, wine, champagne, these are all fermented. Beer is fermented by yeast, wine is fermented grapes, champagne. This goes through a double fermentation process. And then if they're distilled, if the beverages are distilled, it actually increases their alcohol content. All right, so something like whiskey or vodka or Absolut ethanol has 20 to 90% alcohol. I want you to know, and I think I have this written on the second page, but the proof of an alcohol is actually 2 times the percent. So for example, if I wanted to know 40%, this would be 2 times a 40%, which would be 80 proof. So this 40% would be 2 times 40, which would be 80% proof. Let's do this 6% ethanol, because beer is anywhere from 4.5 to 6. That's a pretty common amount of ethanol, 4.5. Beer can be as low as 1% ethanol if it's a light beer. A light beer would be actually lower amounts of alcohol. And that's why it's light, so it has lower calories, but it also has a smaller amount of alcohol, so it could be a 1%. That's how they cut down the calories. So if we just took this 6% ethanol here, this would be 2 times that percent ethanol. So 2 times 6, this would actually be a 12 proof alcohol. So that's how you convert those numbers. All right, moving on to the next page, and there it is. Again, there's that 2 times percent ethanol to get you that proof. All right, so let's talk about some specifics, a few more specifics. Whiskey is 2 times 40%, so it's 80 proof. 100 proof whiskey is 50%, so you can go the other way. You can take the proof, divide it by 2, and you can get the percent by volume. So you can go back and forth between those two numbers. In some countries like Australia, they define a standard drink as 10 grams of ethanol per drink, because this is the amount that you can metabolize in 1 hour. So they actually use different proofs, different numerical measures for our alcohol. Denatured alcohol. This is actually, get this, this is 200 proof. So think about that. If we take our 200 proof, we divide it by 2, this is actually 100% alcohol. 100% alcohol. 180 proof would be 90% alcohol. So hopefully you're getting the point here. You're getting this pattern that's developed. All right, so that's a little bit about the drinks. How about the pharmacokinetics? The pharmacokinetics of these. The routes of entry. Well, you guys know that most of the time alcohol is orally ingested. So oral ingestion is the route of entry. It can be inhaled. It can actually also be absorbed transdermally. So, for example, a small amount might be significant in a baby if it's just exposed. It also can be exposed intravenously or brought right into the vein. All right, so intravenously means brought right into the vein. All right, so absorption is rapid into the blood. It depends on several factors. So this is one that's pretty important. Presence of food in the stomach. This is actually called gastric emptying. It's how quickly do we empty our stomach. So when you eat food, it sits in your stomach, and if you eat a large meal, it takes a long time to empty your stomach. However, if you go ahead and drink alcohol on an empty stomach, that alcohol is going to be absorbed from that small intestine really quickly because your stomach is going to empty very fast. Okay, so if you drink alcohol with an empty stomach, you're going to have a faster absorption. Excuse me 1 minute. Sorry about that. My babysitter, which is actually the same as a screen, is Fortnite right now for my kids. That's what they're enjoying playing, which means they get really loud and really into it and start screaming and yelling, and it's sort of annoying. So I'm so sorry. All right, so most of the, like I said, most of the absorption occurs in the small intestine. We're talking 75% of the absorption of alcohol. A small amount if it sits in your stomach for a while. If that gastric emptying is fairly slow, about 25% of that alcohol absorption can happen in your stomach. All right, because there is some blood transfer. So really what it has to do is it has to get into the blood from either the stomach or the small intestine. And it has to go through the gastric and mesenteric veins into the hepatic portal, vein, and then into the liver. All right, once it gets into the liver, that's when the metabolism of ethanol is going to begin. So if you look, it really has to get from the stomach to the small intestine, into the blood, and then into the hepatic portal, which then it can go into the liver and be metabolized there. So it does take some time to do that. Ethanol that's not metabolized returns to the heart, into the general circulation. So about 90 seconds to the brain, and the ethanol creates the effects. So you get the effect of the drugs. A little bit about body fat and water. All right, so ethanol is actually mixed with water, not fat. So the more water somebody has in their body, the higher water content, that actually affects the absorption of their alcohol. And this has to do with really more male versus female characteristics. All right, I'm actually going to use this bottom portion of my notes here. So men, you tend to have lower amounts of fat. All right, girls, don't take it personally. It just has to do with insulation and childbearing and all of that. All right, women, you have a higher amount of fat. Makes your skin softer and all that. Makes you it's harder for a woman to have defined muscles because of that layer of fat right around her muscles. All right, so this larger amount of fat for women actually makes a lower amount of water. Now let's contrast that to the man. If he has less, a little bit less fat, he has a higher amount of water in his body, which makes a faster absorption. So faster absorption for a man and a slower absorption for a female. However, there is less fluid to dilute the alcohol. So even though the absorption has a different speed, there's less alcohol dilution in a female because of that lower amount of water. All right. So men, you have that faster absorption, but females, even though you have a slower absorption, you have less fluid to dilute the alcohol. So it sort of balances it out a little bit. All right, so ethanol, again, one of the characteristics with ethanol is that it easily mixes with your body water. And so women, you have a smaller body mass, less water volumes. So this actually makes you have a slower absorption. All right. So the half-life of the ethanol. Ethanol is actually processed by the body, especially in the liver, at a fixed rate. Increasing the concentration will not increase the clearance of processing rate. So what I'm saying is, if we increase the concentration, it's still going to do 1 drink per hour. So increasing the concentration is actually not going to increase the rate at which it's processed. The reason is we actually have a certain rate at which we can break down the alcohol. I'm actually going to go back to this page one more, and talk about these rate limiting steps, because that's essentially what I'm talking about right here, is how come we can't break down the alcohol any faster. And it's because of specific enzymes. If you go back in your brain to how enzymes work with a lock and key mechanism. And once the substrate locks into the enzyme, it breaks it down that way. Well, enzymes can't work any faster than their fastest. And their fastest processing is 1 drink in about an hour. And it's the enzymes that actually limit the rate of breakdown. All right, so we've got blood alcohol content as our next concept that you guys need to know. And funny, I'm going to teach you how to calculate your blood alcohol content, but there's actually an app you can get on your phone. I didn't get it because I didn't want to deal with it, but you could actually type in the amount of drinks you have, your body weight, and the type of drink, the percentage of alcohol, and you can determine your blood alcohol content. So you can actually calculate numerically on your phone what your blood alcohol content is, so you can make sure that you're behaving responsibly. So I'm not totally sure all of you guys will do that, but the function is there. So if you ever wanted to take a look at that, I think that's pretty cool. So what is it? Well, the blood alcohol content is really just the grams of alcohol, your grams of alcohol, divided by your 100 milliliters of your blood. So for example, if we took a blood alcohol content of 0.08%, and we just put that into this equation, that would be 0.08 grams of alcohol divided by your 100 milliliters of blood. So that's what that means, that blood alcohol content. All right, so 0.08% just means 0.08 grams of alcohol divided or in every 100 milliliters of your blood. Again, your liver can only metabolize 1 drink per hour. It's metabolized at a fixed rate. So you just sometimes need to wait it out. All right, so if we took, say, a blood alcohol content of 0.02%, hopefully you've got that. I'm just putting in some different numbers for the same thing. This is actually 0.02 grams divided by every 100 grams of blood. Okay, so let's determine how the app, if you ever downloaded that app on your phone to determine your blood alcohol content, what would that actually be doing? I need like a blank sheet of paper. I'm just going to show you that real quick. I'll come back to that bottom portion. But what I want to talk to you about is how to determine that blood alcohol content. So blood alcohol content You're probably wondering, how do we use a breathalyzer to determine blood alcohol content? Because why wouldn't the police officer, if they're pulling somebody over and suspecting alcohol in their bloodstream, why wouldn't they just take some blood? All right. Well, first of all, it's sort of dangerous because you don't know what type of diseases can be transmitted. We don't want to touch anyone's blood if we don't have to. But there's this law called Henry's Law that was actually developed, and he said that the amount of alcohol in your blood is proportionate to, guess what? The alcohol in your breath. So you can actually use a breathalyzer to get the amount of alcohol in your blood. And that's what our police officers do. So they use a breathalyzer, and they use Henry's Law to determine the amount of alcohol in your blood. So we said it burns off at a rate of 1 drink per hour. What is that in terms of percentage? That actually is 0.015% per hour. So what do I mean by that? Well, your body can metabolize or break down, burn off, metabolize alcohol at a rate of 0.015% per hour. All right, that's your rate of metabolizing. All right, so let's do 2 side by sides. Let's do a male and a female. We're almost done. Hang in there. All right, so we have a female on this side. We have a male over here. Now, females actually have a different constant. Remember, we talked about the amount of fat in our bodies versus the amount of fat in a male's body. So males, you have a constant of 0.68, and this is the constant. Let me sound out my words, huh? This is bad. Constant. And 0.55 is the female's constant. All right. So what we can actually do is we can multiply the constant times the number of ounces that you're drinking times the percent of alcohol. And this is, like I said, this is what your blood alcohol content calculator is going to do on your phone, divided by your body weight. And that's going to give you your blood alcohol content. All right. So let's go ahead and do that. We've got, let's take a 24-ounce drink. Let's take 2 beers. Okay, so 0.68 times 24 ounces, 2 12-ounce drinks, times, let's take 2 12-ounce beers. So let's go ahead and take a normal amount of alcohol for a beer. And let's take 175 pounds for that person. If we went ahead and plugged all of those numbers in, we would actually get a blood alcohol content of 0.03. So that means that this person, this 175-pound male, could drink 2 beers at a normal percent alcohol, and their blood alcohol content would be 0.03. All right. Just for your values, I'm sure that you learned this in health class. You know that 0.06 to 0.08 is impairment. At least I'm assuming you know that from health. And that 0.08 is legal intoxication. All right. Now, we also talked about, and that was in New York State. Sorry. And we also talked about other variables, right? We talked about gastric emptying and how quickly that stomach is absorbing or passing your food through to the small intestine, because 75% of absorption happens there. So we already talked about that. So there are variables, but this is sort of a standard process. If these 2 beers were drunk in a normal rate, how would that blood alcohol content be affected? So let's do females just to see. By the way, this was approximately 0.02796. So just to give you that idea, that was my number that I got, 0.02796. If I multiplied all 3 of these numbers, divided it by 175 pounds. And I did need to convert some numbers, but that's okay. We got the point. So females, to get our blood alcohol content, And we've got 0.55 times